Welcome to Books and Beyond. Today, I want to talk about pi and Euler's number E. And why is it that almost everyone has heard of pi and not so many have heard of E? Why is it we celebrate Pi Day internationally and, well, E Day only by a few? Pi and Euler's number are both irrational numbers. They are mathematical constants with important and distinct roles in mathematics. Pi is the ratio of a circle's circumference to its diameter. It's an irrational number, meaning its decimal representation never repeats and never ends. Pi is commonly used in geometry and trigonometry and has a special place in the study of circles. Euler's number, E, is an irrational number as well, approximately equal to 2.71828. Although commonly associated with the Swiss mathematician Euler, Leonhard Euler, it was first discovered by the mathematician Jacob Bernoulli in 1683. It is the base of the natural logarithm and has applications in calculus, particularly in the study of exponential growth and decay. Now, regarding the question about why pi is more popular than E, it might be due to the fact that pi is more intuitive and visually appealing concept. The idea of circles is prevalent in geometry, and many people encounter pi when learning about circles in school. On the other hand, the applications of E, while fundamental in mathematics, may be less immediately obvious to people who are not deeply involved in advanced mathematics or science. As I mentioned, pi has a cultural significance and it is often used in popular culture, including references in literature, movies, and even celebrations like Pi Day on March 14th. This might contribute to its greater recognition among the general public compared to Euler's number. Ironically, the symbol of pi was made popular by the mathematician himself, Leonhard Euler, in 1737, although it has been around more than 4,000 years and recognized by the Babylonians. It's worth noting that both pi and e are important and widely used in various branches of mathematics and science, each in its own context. They serve different purposes and are not directly comparable in terms of popularity. Well, here today, I want to talk to Riley Jensen about this question itself. I'm here today with Riley Jensen, electrical engineer, to talk about pi and Euler's number E. Welcome to Books and Beyond, Riley.
Hi.
So I have a few questions for you. As an electrical engineer, and I consider you an expert, pi is celebrated widely on March 14th. Why do you think pi is more popular compared to Euler's number E?
Well, pi is related to circles, naturally. And people see circles in a lot of places. For your average person, I think it has an immense amount of utility. E also, of course, has enormous power, but really only for nerds like myself. Most people don't actually need logarithms in their day-to-day life, I think. That doesn't mean they're not worth learning. Anyway, so yeah, pi is used for all these circles, and also pi has been around for a very long time. People have, there's a lot more cultural artifacts built up around pi. And there's been a lot more people who have talked about it and so on. So those are probably why it's a lot more popular. Also, it has its own unique symbol, which is quite cool. Well, it's a letter from the Greek alphabet that everybody recognizes, right? Whereas E is just another letter of the English alphabet. I don't know. I think that increases its recognition a bit.
I was thinking about that also. Also, I read up that it was actually Euler who popularized pi.
You mean the symbol or the letter?
The symbol.
Oh, really? Mm-hmm. Yeah. Euler coined a lot of really important milestones in his work. One of the most important mathematicians to ever live, from what I hear from math people. He also shows up a lot, so I take their word for it.
Why do you think degrees is more popular than radians? I mean, pi is popular, but why is it when we're talking about circles, everyone also always says that the circumference is 360 degrees rather than using pi, for example?
Well, the first idea of using degrees as the number for a circle, like it could be any arbitrary number you want, really. We could have said there's 1 degree in a circle, but we picked the number 360. And originally, I think it was because there's 365 days in a year, and the Earth's orbit is very nearly circular. And so they just shaved off 5 days because 360 is divisible by a lot of numbers. And it's a very nice number to use in that consideration. And that's where the 360 number came from. And I think that has a lot more recognition inherently because of that reason, because of the Earth's circular orbit, than, when you say there's 2 pi radians in a circle, people are like, what does that even mean? Well, yeah, we know what that means, of course, but it's, it's a little harder to intuit. And there's a reason I think people prefer degrees to radians. Also, I much prefer the unit of hertz and 1/seconds as opposed to radians per second, because I can really intuit it a lot better. Because when you're thinking about like an oscillator and I tell you it operates at 10 hertz or whatever, I know that means it's happening 10 times a second, right? But if I, put that in radians, it becomes less immediately obvious to me what is actually happening. That's probably why degrees are more popular than radians.
That makes sense. Well, for someone who is very familiar with advanced mathematics, how would you explain the significance of pi and e in everyday terms?
Oh, well, first, I'm not a extremely skilled mathematician. I'm just an engineer who's used a lot of it. Well, both of these constants show up all over the place in mathematics for whatever reason. And pi shows up in a surprisingly large amount of equations that have to do with circulation or circles or repetition. And e shows up in a lot of equations that involve exponentiation of some kind. And both of those features are very common in many aspects of life. Going around something or repeating something or growing something. Both of those are very important concepts to understand, especially for like compounding interest.
Mm-hmm.
Now, of course, you might not use a E as a base power when you're calculating your interest rate, but the intuition that you'll develop upon studying exponents, where E is essential, is absolutely necessary to understand all that. And people get confused all the time about compounding interest and so on, even though it has profound implications for one's life and work and so on. And that's how credit cards get you with, they say, oh, it's only 8%. Well, 8% is a lot. So that's where exponents are useful. And log scales are also really important for anyone in any STEM field, of course. Yeah, E is really important. Also, with E, you get Euler's formula. You don't need pi and Euler's formula.
Well, that's interesting. Okay, so here's a question for you where we have pi and e merge. You probably could tell me more about this one. It's the famous equation known as Euler's identity, where it's e raised to the I times pi plus 1 equals 0. Can you talk about that somehow in a more simplified way for those listening?
Yeah. So the best way to think about complex numbers for me is it's like a plane. And of course, I'm sure some astute mathematician will tell me, well, this is why the square root of -1 actually works this other way, but this is how I think about it. If you have a complex number, the real part points you to a coordinate, and the imaginary part points you to another coordinate. And so, J, we call it J in electrical engineering because we don't like to use I for that because it can be confused with current. So we use J, but never mind that. So you have a plane, right? You have your imaginary axis and you have your real axis. And if you have an equation of a circle, sine will tell you your vertical axis and cosine will tell you your horizontal axis. And so if you want to do pi rotations on the complex plane, you use e to the j pi power, right? Which takes you all the way back to -1. And then if you add 1, you get 0 exactly. So, of course, e to the j pi over 2 is 1j and so on. So really, the e to the j operator is just swirling you around the middle unit circle on the complex plane. So Euler's formula, which is e to the j x is cosine x plus j sine x, right? That is that's where Euler's identity comes from, and it shows you the whole circle on which it lives in. Because Euler's identity is just one, it's one set of all of what Euler's formula tells you. And Euler's identity is beautiful because it relates an imaginary number, an irrational number, an integer, and exponentiation and addition and multiplication all together. So it really has everything in it, and that's why it's so well known and appreciated.
Well, that's a beautiful thing. Okay, so I'm going to lighten it up a little bit. If you had to choose between inviting pi or e to a dinner party, which one would you choose and why?
Probably E, because I think pi gets too much attention. He's probably an asshole. He probably thinks he's really cool because everybody knows who he is. Yeah. So sorry, you're out.
Well, I think we should make E. I mean, obviously, it's known that E Day is February 7th, 2.7. Um,
Mhm.
but I almost forget to celebrate, and I always celebrate Pi Day. So I think I'm going to make
Mhm.
it for 2024 resolution to celebrate E Day as well.
Okay. Well, that's an easy one to hold. A lot of people make the mistake of picking a poor New Year's resolution. I think there's a lot of wisdom in picking an easy one.
Yeah. Hey, if you have a reason to celebrate something, then why not?
Mhm.
Anything else you'd like to say about pi or e that most people might know that you can elaborate on?
I mean, not really. They're both irrational numbers. They're both really useful. They both show up all over the place in bizarre locations. Like you can study all sorts of fields of math and you're just fumbling around with some equation and then pi shows up out of nowhere and you're like, who invited you? Like this is we were talking about like you're studying like probability and all of a sudden pi shows up and it's like why I don't understand, but it's still there. So it can be fun when those things show up. I think E has less of a tendency to show up in that manner, but he still sneaks in from time to time. I don't really have anything else to say on that.
All right. Well, thank you, Riley, for your expertise and for joining me today. And until next time, stay curious and have a wonderful day.
Okay, bye.
Bye.